with functions. This is gonna be the new stuff for the test that's coming up. I don't know whenever we get finished with functions. Now, when I say to you functions, that's really this big, giant, broad category that lots and lots of things fit in, like lines and parabolas and x to the third power when you graph those. It can even include things like piecewise functions and step functions, which you probably don't know about yet, but you will. So when I say functions to you, it's a very general, broad spectrum of things that we can learn. But we're going to go back to the very basics. If you happen to have had me in the 8th grade, we started functions then. And we talked about, in my class, we do this big giant box, and we plugged in all these x values and got out all these y values. And that's when we started talking about functions, okay? So the rule, or the definition really of a function is, it's a relation in which each element of the domain is paired with exactly one element of the range. Now, that probably sounds like gibberish, right? Because you don't know or you haven't seen these words in a really long time. So what does it mean to be a relation? What do you think of when you hear the word relation? Somebody say something. Relationships. So in a relationship, hopefully, it's only two people, right? You and the other person. Hopefully. So in in math, the relationship is the x and the y. It's what x am I plugging in, what y value is it giving me out, okay? So it's a set of ordered pairs. Remember, x and y in a parenthesis is called an ordered pair. So that's a set of ordered pairs. So like x, y. Now, so that's what that is. It's a relation. So meaning it's a whole bunch of x's and y's that go together. In which each element of the domain, what does domain mean? Y'all remember domain versus range? Domain goes with which one?
X.
The x. And range goes with the y. So here's what it says. Each x is paired with exactly one y. Each x can only have one y. So let me give you a list example here. Whoops, I don't want to use x. I want to use them. One of these is a function, one is not. Okay, one of those is a function, one is not. Each x can only have one y. Each x can only have one y. So, what's the x here?
1.
1, and the y that goes with it is 3. 2 goes with 4, and 1 goes with 6. Wait a minute, I thought 1 went with 3. Uh-oh. Each x can only have one y. This x has how many y's? It's 2. So this one is not a function. One goes to 2, 3 goes with 4, 5 goes to 6. This one is a function. Okay. So what does that look like in a graph? In a graph, if I have the same x value that has two y values, so let's say it's 1 for the x, right? What if I have 1, 2, and 1, 5? So 1, 2, 1, 5. See how they're lined up vertically? That's what causes an issue. When you have a graph that kind of goes back over itself, then you're going to end up with one x that has two different y values. So the rule is this. It can curve all day long as it doesn't curve back under itself. But when it comes back under itself, then you're gonna have an issue. You're gonna have one X with two different Y values. So the way that you can check it, if something's already graphed, you can do what's called the vertical line test. So you can use your pencil or your marker and you can pass over it. If it ever touches it in more than one spot at a time, then it's not gonna be a function. So now let's just look at some pictures. So if these were on a graph, which one of these would be functions, which one would not be a function? So this one, does it ever curve under itself? No. So it should be a function. And you can check with vertical line. You can actually draw vertical lines. If they ever cross it more than one time, it would not be a function. Those don't cross it more than once, so it's a function. What about this one? Uh-oh. It crosses it here, here, here. That's not a function. What about here? This one curves, but does it curve over itself? Now, each of these X values will only have one Y value. So that one is a function. What about this one? None of those cross it more than once, do they? So this one is a function. What about if I did something like this? This is a parabola, but what if I kind of did like a sideways parabola? Is that going to be a function or not? No, because it curves underneath itself. So that vertical line would cross it twice. In other words, whatever X value that is, it would have two different Y values that went with it. So that's what makes it be not a function. Everybody understand that part of it? Okay. Now for us, what you're used to seeing when we do this is we're really introducing you to functions. We start out with lines. So let's look at a linear function. That's a big word, linear. It just means it's line. It's a line. So linear functions. Now the most popular way to look at a linear function is what we call slope-intercept. Slope-intercept is y equals, who remembers it? It's been a while, right? Y equals mx plus b. This is your y-intercept. This is your slope. Remember, slope is the rise over run. Begin with B, move M when you start to graph it. But this is your your slope intercept. Now, mathematicians are good at math. They're not creative. So if they give it a name, it's because it tells you what it does. It's called the slope intercept form. Well, it gives you the slope and then the intercept. Okay? That's why it's called that. Slope intercept form. All right? So now let's just work a couple of problems for graphing. I'm going to give you a couple of problems where you're telling me if it's a function or not a function, and then we're going to do some graphing of linear functions, okay? That's what we're going to do today. All right, so let's do that real quick. So let's start simple. Y equals 1/2 x minus 4. Remember, this is the one time, slope is the one time you want a fraction. If it's not a fraction, we got to make it one, so we have to put a line with a 1 under it, remember? Because we want it to be a fraction. All right, so tell me the slope of this line and the y-intercept of this line. What's the m and what's the b?
The 1/2 is the m, and then minus 4 is b.
Yes. Don't put the X with the slope. A lot of people will put the X there, but the slope is only the part in front of the X, okay? And then the B is a -4. So if I were gonna graph this, we'll pretend that's straight. Okay. So I'm gonna begin, you always start with this. This is your beginning point. Slope tells you the slant of the line, but you have to know a starting point. So you have to know one point on the line before you can count to the next point. So for us, B is gonna be our beginning point. It's the point we put first. It's the y-intercept. So just like in football, if somebody intercepts the football, it means they come between where the football's going. They cross its path. Well, that's what's happening here. This is the line, this line that we're gonna graph crosses the y-axis at this point. So it's your beginning point, so go down 4. Yeah, I go down because it's negative. 1, 2, 3, 4, put a dot. From that dot, I count the slope. 1 up, remember it's rise first, then run. 2 to the right. So I'm gonna go up 1, 2, right. And I can keep doing that, up 1, 2, right. And I still end up with points on that line. Now if you run out of graph space, you can go the other direction. You just kind of have to think through the process. This is a positive. What other way do I have to get a positive when I'm dividing? 2 negatives will also make a positive. So I could do this as a -1 over a -2, which would mean not up, but down, then not right, but left. Down and left will also give me a point on this line. If I go down 1 and left 2, I'm still on this line. So that is the graph of that linear function. Now, we just talked about how do we know if it's a function or not. Well, does it curve underneath itself at any point? No, it's a straight line. If I pass this marker over this line, nowhere is it going to touch the line in more than one spot. So these are, in fact, functions. Okay. All right, let's do another one. What if I have y is equal to -2/3, I'm going to write it out like this, -2/3 x plus 3. Alright, so I still want you to tell me the M and the B, and then we're going to graph it. Alright, what's the M on this one? -2/3. The B is +3. So I'm going to begin up 3, and then from that down, I'm going to count the slope. But this is where everybody gets confused. What does -2/3 mean? Okay, I want you to tell me which one is right. If it says -2/3, does that mean this or this? Or this?
Can it be, I say, can it be both?
It can be both of these, right? A negative divided by a positive is still a negative fraction. And a positive divided by a negative is still a negative fraction. But what about this?
No, because that would be a positive.
That would be a positive. Can't use 2 negatives. I can use 1 negative anywhere I want to. On the top or on the bottom. I just can't use it both places because that would make it be
So
positive.
it doesn't matter.
Alright, so from here, I'm going to go down 2, 3, right. I always like to go down if possible, and then always go to the right. So I like to go down 2, right 3. Okay. If I went the other way, if I went to -3, I would go up 2 and 3 left. So I would need to go up 2 and 3 left. 1, 2, 3. I'm still on that line. All right, let's see if I can draw this straight line. Probably not. okay? You'd still be on that line if you went up to left 3. Now, of course, this is math, so it doesn't just end right here, does it? Of course not. So sometimes you have them that aren't solved for y, but we've already done literal equations where you learn how to solve for a variable. So you can just move the x over and divide if something's by the y and get it to say y equals something, okay? But we're not gonna work on those today. What we're gonna work on today is recognizing if it's a function or not, whether it's an ordered pair or a graph, and then I am gonna give you a few of these to actually graph. Now, when you open it up in Kami, you can change the font size on your paintbrush to like a 6, and when you click on that B part, right, you can just click it and it'll make a circle for you. And then you can count the slope up and over and do that. And then there's on the shapes, it's like a circle inside of a square. You can actually create a line between those two. It doesn't have to be exact. I'm not looking for exact. What I'm really looking for are the 2 dots to make sure you put them in the right place, okay? So you can use Kami to actually graph with it. And then you can type your answers like function or not a function beside those problems when I put that out there in just a few minutes, okay? All right, if you have any questions, we'll go over these tomorrow again with another video. If you have any questions in the meantime, call me, text me, send me an email on Schoology as well if you need to, okay?